Hello students, let us see this question. A block of mass m slides on a wooden wedge which is in turn slides backward on the horizontal surface. The acceleration of the block with respect to the wedges. So some details are given here. So we have to first draw the free body diagram. So first let me draw the free body diagram of bigger mass. So you can see that the weight is acting directly downside, and here this block is touching. So we have a normal force is there. This normal force we will make into components. That means downside component is n cos 30 and vertical component is vertical component is n cos 30 and horizontal component is n sin 30. So we can write from here, from the free body diagram, n sin 30 is equal to minus ma1. Why this minus? Because this wedge is moving backward. So we can say that n into half is equal to 16 a1, because mass is given as 16. So a1 is equal to uh, so n is equal to 32 a1. That is our first equation. Now let me see what is the free body diagram of a second body. Second body, you know that automatically normal force is acting perpendicular to this slope. That means this inclined plane. So that is n. And automatically there will be a pseudo force acting because this small body is on non-inertial frame of reference automatically, and that means the body is moving. That is the meaning of non-inertial frame. In that, we have to uh, take a pseudo force that will be acting just opposite of the words, so that we can see that F is equal to 8a1. Okay, that means how we will take that one. That is nothing but acceleration of the wedge and mass of the small body. That is a very important thing. And this normal and this pseudo force we will resolve into components. So look at this. This normal we can a normal force, you know that it will be likewise. See, 8g is a downside, and it will be resolved into two components. That is 8 8a1 cos 30 plus mg sin 30, and here we can see that mg cos 30. So mg cos 30 and mg sin 30 will come, and the pseudo force also we will resolve into components. Pseudo force component is one is that normal force plus 8a1 sin 30, and here we can say that 8a1 cos 30. So from this we can okay, compare the perpendicular components. Mg cos 30 is equal to n plus 8a1 cos 30. You look at that. And then we will substitute the values of mg. We know that 8 into gravitation into root 3 by 2 is equal to n. We already got it, 32a1 plus 8a1 into half. So we substitute all the values. From here, just solve it. So we will get a1 is equal to 0 3 by 9. You can just see, because of time constraints I am not explaining all the steps. That is the simplification. A1 we will get it as g root 3 by 9 meter per second square. Then consider the components along the inclined plane. Now we will consider the component along the inclined plane, that is 8a1 cos 30 plus mg sin 30. In that speed the force is acting, so we can say that it is ma2. So after substituting all these things, we have a2 is equal to g by 2 plus g by 6, or we will get 2g by 3. Then we know that it is actually one wedge. This mass is moving over the wedge, so relative acceleration will be there. So that is in the same direction we have to take. So a2 minus a1 cos 30, because both should be in a horizontal. A2 will be acting backside, then front A1 cos 30 will be there. So after substituting all these things, 2g by 3 minus g root 3 by 9 into cos 30 value root 3 by 2. So after simplification we will get the relative acceleration is g by 3. Actually the options here are not given, so this is according to my calculation.